In this video, I'm going to show you how to run an incrementality study in your Meta Ads account. Hi, I'm Brendan. I'm the co-founder of an application called Stella that makes incrementality testing extremely easy for brands spending over $80K a month on ads. And in this video, I'm going to show you how to do a channel level incrementality study. In a different video, I'll show you how to do a campaign level study. When it comes to ASC campaigns, it gets a little tricky. So the first thing we have to do is set up our study correctly. I can't tell you how many times people come to us at Stella and they say, hey, we ran an incrementality study ourselves months ago. We didn't get a conclusive result, and we want to see if you guys are able to take that data and run and get a good result. The biggest issue we see are people did not set up the study correctly and they picked the wrong holdout locations. So these are all things that Stella can help you with. So to start our incrementality study within Meta, let's actually start in Stella. So in Stella, we can create a new study. And Stella is an AI agent for marketing measurement. So it'll walk us through step by step. Will walk us through each step to create our study properly. So let's name this like test study Meta ads. Submit. And now Stella will take us to the next step. The next thing is select the test platform, which in this case would be Meta or Facebook. And then the success metric platform would be a platform other than Facebook. We don't want to measure success based off of Facebook conversions. Obviously, if we turn off ads in a certain state on Meta, we're going to see 0 conversions in Meta. But what we want to look at is the impact on total revenue coming from Shopify. So let's submit. And now we get to select the test types. So Stella offers 3 different test types: geo holdout, inverse holdouts, and tests. This is really important to select this correctly because it changes the data models we use in the backend and how you would set up your test. Just so you know, incrementality studies are often said to be geo holdout studies. Technically, most incrementality studies are actually inverse holdouts, meaning we had ads live before and then during the test we're turning off locations. Whereas a geo holdout by definition is activating ads and purposely holding out a few locations. So for example, if you're activating Meta for the first time for a new client, this might be a geo holdout. But if you already have a client spending money on Meta, you're likely going to do an inverse holdout. And this is obviously something you can ask Stella about. What test should I pick? Test type should I pick? And Stella can read everything on the screen and explain to you what you should do. You could also be a little bit more thorough with Stella and say, this is my exact situation. What should I do to set up this test? Anyways, let's submit and go to the next steps. So like I said before, this is the step that everyone gets wrong who isn't using Stella or a statistical methodology of selecting test and control regions. So Stella, we have a built-in automatic location selection tool. So I'll toggle over to there now, where we'll take this template, import the last 90 to 120 days of sales data, and Stella will tell us the best locations to turn off for this experiment, how long we'll need to turn off those locations, and how much spend will need to be held back to reach statistical significance. So I have some test data over here. Let me just pull this here and we can do date. I'll move this out of the way. Location and revenue, and we'll press submit next steps. Cool. Let me move this up here maybe. So Stella will run this for the next 5 minutes or so, and the export will be 6 different location options, 3 for geo holdouts and 3 for inverse holdouts. So I'll pause the video and I'll come back when Stella's done processing. Okay, now Stella is done processing, and this is kind of the output that we get. So we have 6 different options here, and the first 3 are typically for a geo holdout study. And the reason being is the effect size is positive. So these are 3 options we could choose if we wanted a geo holdout study. Since this is an inverse holdout, meaning we have Meta ads live now and we'll be turning them off, we want to look at anything with a negative effect size here. So these three options are our best bet. So now what we can do is look at duration, which are basically all of these are minimum recommendations. So a minimum of 20-day duration Stella's recommending with a minimum of, $7,000 or almost $5,000 held back to reach statistical significance within those 20 days. If we can hold back more, that would even be better for our data models. And then the last thing we look at is model fit. So model fit, we want the closest number to 0 as possible, meaning Stella's synthetic data model she ran on the back end are close to what should happen in real life. Was like 100% accurate. It'll never be 0. We've seen it get to like 9 to 10% model fit. For some reason, this data set is giving us a larger model fit, but it looks like this option is our best option because we have the lowest investment and the lowest model fit out of all of the other options. So it looks like for this study, we will turn off ads in DC, Indiana, New Jersey, and New York. And then we'll keep ads live in all other states in the United States. So let's go back to study form. We can switch this to states, do District of Columbia, Indiana, New Jersey, and New York. And then typically what we recommend at Stella, if you're testing within the same continent, so if you're doing the United States and Canada, we would recommend putting in all other states as your control. But if you're doing a global incrementality study, you're going to need to pick your control groups a little bit more selectively based on population size, average conversion rate, average sale volume in those regions. But for now, we'll just use all other states as a control. And this is good because if something happens, if an external factor happens, like a sale happens across all of America, Stella will be able to pick this up because it'll see a jump in all the control states and it might see a jump in the test states as well, like a jump of sales. And Stella will be able to isolate that and say that is something that happened nationwide and not specific to this test. So we'll submit it. And the next part is asking us for the dates. And if you're creating an incrementality study, typically you would put today's date and then 20 days from now to be the end date. However, since I'm using test data, I'm going to use October 20th to November 10th. So let's do that, October 20th to November 10th, and we'll submit. So we've set up our study perfectly within Stella. Now let's go back to meta ads to actually remove those locations. So in meta ads, you could go in campaign by campaign and exclude these locations. That may reset learning phase. And if you're doing a channel level analysis on all of meta, it's actually better to do it on the account level. So let me show you how to do that right now. So if we go to all tools and we go to advertising settings and then account controls and then audience controls, you can select my business can only advertise in specific locations. And here you can exclude New York. I want the whole state. New York, New Jersey. Give us Indiana. What was the last one? Last one was District of Columbia. Was it DC? Maybe it's DC. Washington, DC. Cool. And then you will then click review changes. So you'll just exclude these locations and then review changes and launch. Sometimes doing it this way may take up to 48 hours for the changes to go into effect. Typically we see it shorter than that. So just keep in mind with that when you're analyzing the results. So we'll click review changes and go. Since this is just a test example, I'm not going to actually do it, but that is how you would set it up. And now you just wait those 20 days. I've worked with a lot of agencies, like agency partners with Stella, that like to put new campaigns always in the account and rotating. And that's fine to continue that habit with the account controls the audience controls at the account level. But if you're doing a campaign level, you have to be a little more cautious of things like that. So now let's say 20 days have passed and we're ready to analyze the results. What do we do now? we need to export the data from Meta and then export a different set of data from Shopify. And I'll show you how to do that right now. So if we go back to Stella, we go to this post-test analysis tab, and Stella has a template here. So let's just make a copy of this template. And in this template, we have three main tabs. Obviously, we have the instruction tabs that kind of explain what I'm about to explain. The first tab is we need cost by city by day. So this is spend coming from Meta. Then in the revenue tab, this is from Shopify, we need revenue and orders by day by state. And then finally, we have a consolidated tab, which combines everything together to run within Stella's final analysis. So let me show you how to pull this data within each platform. So in Meta, if we go to reporting, we can click create report and a pivot table, and Stella's going to give a bunch of, Meta is going to give a bunch of options that we don't really need. We only need amount spent, but they like to have attribution and then schedule. I don't know why they put schedule. All right, so we have amount spent. Now we want to do region by day. And then typically what we look for in Stella is 90 to 120 days of data, including the test period. So the last 20 days of that 90 or 120 should be when the test ran. We do this because Stella is looking at pre-data to understand what is predicted during the test and see how far that deviates to what actually happened. So let's just say we're doing 90 days. I don't know if this is actually 90. We'll update. Now we have spend by day by state, and we can export this as a CSV. Next, within Shopify, we'll just go to the analytics tab and we'll update this report a bit. First, we'll make sure that we're at last 90 days. We can do gross sales. It's up to you what type of sales you want to use. You can use gross sales, net sales, or sometimes we do new customer sales, like new customer revenue, to see the overall impact of acquiring new customers rather than just returning customers. So let's add in a couple columns here. So orders. And then we want to add in a dimension. I might need to move this day. And then we want billing region. You can also do shipping region. Most of the time it's the same. Cool. So now we have the last 90 days of state, how much revenue was generated in that state, and how many total sales there were. And we can export this, if I move this thing over, export to a CSV. And now we have the data. You might need to update the data within your CSV or a Google Sheet just to make sure it fits the format. But for the most part, it should be good to go. So within Stella's format, you would put day by state by cost from Meta here, revenue and total orders by day by state from Shopify here, and then Stella will combine it into a sheet that looks something like this. So this is, again, I'm just using test data here. So what we can do now is copy the link to this data once this is all set up properly. I always do a pivot table as well. So I'll make a pivot table, and just so I can see when spend actually stopped. Sometimes people think the spend stopped the day they excluded the locations, but it really might have started the next day. So I do some checks, but for the most part, just for this video, I won't. We'll grab the link and we'll go back to Stella and paste it. Stella will ask us to map the fields, date, state, revenue, spend, and orders. And we have advanced options if we want to play with some of the data models or add some, a delay for the model, but we don't need to, and we'll submit and wait for Stella to process. This will take between 5 to 10 minutes. And then when you're done, you'll have that finalized dashboard that gives you your iROAS, your iCPO, shows you the model fit, and then the total impact of turning off ads. So I'll continue recording when that dashboard populates. Okay, and this is the final analysis Stella came back with. So it looks like incremental revenue was negative 33, almost 34,000. Negative in this case, a lot of people are like, why is that negative? This is negative because it's an inverse holdout, and I've explained that a couple times in the video, because we're looking for a negative impact. Like we wanted to see, because we turned ads off, we wanted to see incremental revenue decrease in those states, because if they stayed the same, that would mean the ads had no impact, and if it increased, it would mean ads are actually hurting efficiency. So we held back $4,600 in spend, which I believe is actually pretty spot on to what the recommendation was. 47. So we reached stat sig with 4,600, so we were really close to the original recommendation. And the iROAS Stella's recording is a 7.37, which is very, very incremental in this case. Typically, you don't see an iROAS that high, but it all depends on how you're running performance, how your customers react, if your customers are actively on Meta, and are they in a buying behavior there. It looks like incremental orders were down 600 incremental orders, giving us a cost per order or incremental cost per order of $6.77. We can see the model fit here. So this is basically what Stella predicted would happen compared to what actually happened. You can see Stella was very close. This is incremental revenue during the study. So again, what Stella predicted would happen compared to what actually happened here, where we can see by turning off ads, incremental revenue slowly dipped. There was likely a lag here of turning off ads, but still the effects of those ads were driving incremental revenue. And then finally, we can see the full impact here, where you can kind of start seeing like this is pretty narrow, and then it starts decreasing a little bit more steep to where we're starting to lose the lag effects of the meta ads here for this audience. So yeah, and a couple cool things you can do with Stella is, one, you could download a report where it will create a Google deck, or actually I think it's a PowerPoint presentation with all of these insights and AI generated insights for each chart. So if you need to present this to your client in the next hour, you can do this and it'll download and be ready within a minute. You can also screenshot the entire report. If you're looking at this data and you're like, I don't quite understand what any of this means, you can click on any of these charts, screenshot it, and send it to Stella. And Stella, again, can read everything that's on the screen. You can just say, how do I explain this chart to my non-technical client? So now Stella's looking at the chart, and it'll start explaining what it means, but for you to explain it to your client, if that's what you asked for. It could also just explain it to you. This chart shows the impact of turning off ads in certain regions. The line represents a cumulative incremental revenue, which is additional revenue we would have expected if the ads were still running. So Stella can do that with pretty much any of these charts. You can also ask it, like, we have some default questions here, like what are the 3 biggest insights here? And Stella will start giving you the insights here. I think we all have seen AI chats. The difference with Stella is she's actually reading all the charts and she knows different statistical methods. She understands paid media strategy. So you can also say, my platform ROAS is a 9.5. What is my incrementality factor? And what should I set my platform target ROAS to? So this is one of the biggest questions we would get from a lot of the tests we run. Like, how do we use this insight? Like, how do we use this incremental ROAS number? And Stella can tell you exactly how to. So she's saying your incrementality factor for Meta is 77%, meaning we should set our in-platform target to a 12 instead of, let's say it was a 9 and we were at a 9.5. Stella's saying, let's increase our target to a 12, which might actually reduce spending, but it'll be more efficient. So this is how you can actually take action from these insights here. Or maybe your target ROAS is a 3. You're at a 7.37, meaning you can dramatically scale this account, push a lot more spend through Meta, and still be profitable. So it all depends on your data compared to what Stella is saying. But ultimately, that is how you run an analysis, or that's how you run an incrementality study for Meta in Stella.